Welcome back to AI with Link Fiti, the podcast where we unpack the latest in artificial intelligence. I'm Thomas, and I'm joined, as always, by Candace.
Hey everyone, excited to be here and especially excited about today's topic, a new research paper from DeepSeek AI on reinforcement learning in LMs. It's titled DeepSeek-R1 Incentivizing Reasoning Capability in LMs via Reinforcement Learning.
This paper really caught my eye. They're suggesting that traditional pre-training isn't enough for true reasoning and that reinforcement learning might be the key.
Exactly. It seems they're using a reward mechanism specifically designed to improve the model's reasoning process, not just its answers. They introduced DeepSeek-R1-Zero, trained via RL without instruction tuning, which they say shows powerful and intriguing reasoning behaviors.
That's a strong claim, followed by the disclaimer that these behaviors have issues like poor modality and language mixing, which they aim to address with further reinforcement learning resulting in DeepSeek-R1. They are emphasizing that without specialized RL, the model's performance isn't as optimized. And to be clear, by reasoning, we mean multi-step inference and logic, not just memorization.
Absolutely. They seem to be tackling that with a unique approach, emphasizing the reasoning process over just getting a correct answer. The resulting DeepSeek-R1 achieves performance comparable to OpenAI's GPT-4 on reasoning tasks, which is pretty impressive.
And they're sharing their models, DeepSeek-R1-Zero and DeepSeek-R1, with the research community, which is huge.
Agreed. It will greatly improve advancements in the field. Shall we dive into the details?
Let's do it.
Okay, on page 2, they dive into the background and motivation. They acknowledge that while methods like instruction tuning and RLHAF improve models, they don't necessarily improve general reasoning. It's a specific problem they're targeting.
They're arguing that by focusing on improving reasoning, we're going beyond just aligning with human preferences. That's where their specific approach comes in, using reinforcement learning to encourage the model to learn by thinking through problems.
They say DeepSeek-R1-Zero, trained with RL, already shows strong reasoning, comparable to other models without instruction tuning. Specifically, they 15.6% to 73.1% improvement on certain benchmarks.
Impressive. But they acknowledge issues with modality and language mixing, which they address with DeepSeek-R1, further refining its reasoning capabilities.
Precisely. It's a two-step approach, RL for reasoning, then RL to fix the shortcomings. They use rejection sampling, throwing away the wrong answers, which creates a fine-tuned DeepSeek-R1 model.
Exactly. So they're showing that reinforcement learning improves reasoning, and then they implement a refined RL process to fine-tune the model further.
Right. It seems like they want to highlight how they use a specific reinforcement learning process, but they haven't mentioned any specifics yet. Let's see if the next page has the answer.
Sounds good. Let's move on.
Okay, now we're on page 3, where we get into more detail about their methodology. They call it post-training, loop, scale reinforcement learning on the base model.
They are stating they directly apply reinforcement learning in RL to the base model without relying on supervised fine-tuning such as chain of thought. As an initial step, they are arguing that the core capability of reasoning comes directly from the reinforcement learning.
And they've made the model and code publicly available. They believe their approach unleashes the reasoning abilities of LLMs without relying on curated data.
Exactly. It summarizes their process as a two-stage approach. First, they use RL to develop core reasoning capabilities. Then, they use another round of RL to address issues like poor modality mixing.
It clarifies how DeepSeek-R1 is made two distinct steps. Initial RL gets DeepSeek-R1-Zero, then further training gets DeepSeek-R1. They also note that smaller models can be powerful too through distillation.
Right. They're exploring the idea that smaller models, trained on the data from their larger models, can still maintain high performance.
They give specific examples like DeepSeek-R1, distill Quen with 78% accuracy on AMP 2024, and DeepSeek distill OpenLAME with 57.2% accuracy on MAT-H. They emphasize these are distilled from their larger models and are much more performant.
They summarize that this type of research will benefit the community and then summarize the evaluation results. They state that DeepSeek-R1 is achieving 79% on AIMV 2024, as well as amazing results on the Humanival benchmark.
Yes, and on knowledge-based benchmarks, their model is competitive with, or even surpassing other models. They even mention how DeepSeek-R1 is better than OpenAI 1 and 12 and 27. It's a strong conclusion to this part. It really showcases their method.
Agreed, it gives a clear picture of the results. Let's see what page 4 has in store.
Okay, page 4 begins by summarizing the rest of the model's capabilities, then transitions into the technical details of their methods.
They highlight that DeepSeek-R1 excels in a wide range of tasks, including general question-answer editing and summarization. They also have an impressive controlled win rate of 87.8%.
Now, they're transitioning into section 2, titled Approach, starting with an overview, where they recap their key points. They are stating they are taking a different path from heavily curated data and are focusing on unleashing reasoning through RL.
Yes, they mention they will describe how they use the DeepSeek-R1-Zero model. They emphasize that reinforcement learning has demonstrated significant effectiveness in reasoning tasks.
Now we're getting into the specifics of the DeepSeek-R1-Zero reinforcement learning on the base model section. It's a transition from talking about results to explaining their process.
They begin with section 2.2.1, titled Reinforcement Learning Algorithm.
This is where we finally get the specifics of their RL algorithm. They state they use the Group Relative Policy Optimization, a GRPO algorithm, borrowing concepts from the Proximal Policy Optimization, a PO algorithm.
They're saying they group the actions of the algorithm and use that to build their baseline rather than just one. They include the equations to show the specific implementation of their algorithm.
They break down what each term in those equations means, highlighting how they calculate a mean reward, shown as arc in equation 3. It's pretty technical, but it's clear they're being transparent about their algorithm.
Absolutely. It's great that they're being transparent. I'm curious how they collected the data.
Let's move on then. All right, we're on page 5, and this section focuses on data collection and specifics of their training process.
They start by explaining their template for DeepSeek-R1-Zero prompt, a specific structure for giving the model's prompts. They encourage their model to think through the answer before the actual result.
It's a very specific prompting structure with think and answer tags, emphasizing that they're aiming for the model to show its reasoning. They also get into specifics of how the model gets rewarded.
Yes, in section 2.2.2, reward modeling. They are saying that the reward model is used to encourage the model to think and give correct answers. They are using a rule-based reward system.
This includes accuracy reward, where the models are rewarded if they give the correct answer, and format rewards, which encourage the models to put their reasoning between think and think tags.
So they're rewarding both getting the right answer and demonstrating the correct reasoning steps, focusing on the process. They also specify we do this to remove any reward model from backpropagating through the reinforcement learning process.
Now we have training DeepSeek-R1-Zero, detailing how their models are being trained using the prompts and reward system. They emphasize the template requires DeepSeek-R1-Zero to first produce a reasoning process, followed by the final answer.
They are incentivizing their model to focus on their reasoning process. Then there's a final section, performance, self-imitation process, and the moment of DeepSeek-R1-Zero, that states their performance increases over time.
They mention the average Pass 1 score on AM 2024 went from 15.6% to 73.1%, a huge increase just through the RL process. They also emphasize their process is more effective than the baseline model OpenAI 1 227.
This is a strong ending to this section, highlighting the success of their RL process. Let's see what comes next on page 6.
Okay, on page 6 we start with Table 2, a comparison table showing DeepSeek-R1-Zero and the OpenAI 1 model's performance on benchmarks.
It's a good way to visualize their claims. It includes benchmarks like AIMD2T4, MATH, FIH, 5 and GPQ, and LevCode.
It's a direct comparison that shows DeepSeek-R1-Zero is performing better or comparable to the OpenAI models. They also include Figure 2, which shows AI accuracy of DeepSeek-R1-Zero during training.
That graph shows how the model is learning over time. They claim DeepSeek-R1-Zero attained robust reasoning capabilities without the need for any supervised fine-tuning data.
They are relying solely on RL to improve their model. They also mention how their model is capable of being improved through majority voting.
They are stating they can enhance performance by using a voting scheme, and that using this method is comparable to OpenAI's model.
Exactly. And that's without any further fine-tuning. It highlights the strong base reasoning abilities they've developed. They then introduce the self-imitation process of DeepSeek-R1-Zero, claiming that IL drives a model's ability to improve autonomously.
They are stating that their model is capable of improving itself through this process without human interaction. It's improving its ability to handle complex reasoning tasks over time.
They conclude by referencing Figure 2 and how it shows the model's progress through RL. It seems to be a very important point they wanted to reiterate. Let's see what page 7 has in store.
Sounds good. Let's move to the next page.
All right, we're on page 7, starting with Figure 3, another graph showing DeepSeek-R1-Zero's performance.
It's a graph showing the average response length of DeepSeek-R1-Zero on the training set during the reinforcement learning process. The model's responses get longer as the training goes on.
They make the point that DeepSeek-R1-Zero naturally learns to solve reasoning tasks with more thinking time. The model is learning to solve harder problems with more time. It's an internal result of the training process.
They've enabled their models to be capable of complex tasks. Now they discuss their most remarkable discovery.
They are talking about what they call the model's sophisticated behavior, that it learns over time. The model is developing problem-solving methods that are not explicitly coded.
They state that these behaviors arise spontaneously during the training process. They are creating spontaneous development, which significantly enhances DeepSeek-R1-Zero's reasoning capabilities.
They're saying that their process enables the model to be able to tackle more challenging tasks with greater efficiency and accuracy. They're driving home the capability of their unique reinforcement learning approach.
They describe an aha moment where a pattern of behavior emerges throughout the training, showing that the model's ability to improve is still progressing.
Yes, they state the moment of DeepSeek-R1-Zero is the phenomenon of an aha moment, where the model figures out a more efficient approach to a problem.
It's very interesting. They claim this behavior is not only a testament to the model's growing reasoning abilities, but also a prime example of how reinforcement learning can lead to unexpected and sophisticated outcomes.
It's a philosophical observation and a great moment of reflection for the team who made it. It emphasizes the capability of RL to enable models to think in unexpected ways. They conclude by stating that this aha moment is not only for the model but also for the researchers.
It's a strong statement and a great way to end this section. Let's see what is next on page 8.
Okay, page 8 starts with an example from one of the training runs, a real-world case study of what they've been describing.
Yes, it's table 3, showing a problem and the model's answer with its thought process. It includes the think-ma and think markers. It is a great example of how the aha moment is implemented in the real world.
It's helpful to see a concrete example. It shows how the model is capable of creating an aha moment in real time as it is solving the problem. It's an important point that they wanted to emphasize.
Absolutely, and now they transition into drawback of DeepSeek-R1-Zero. They acknowledge some of the limitations of the model.
They are very clear that even though the model has strong reasoning capabilities, it struggles with poor modality and language mixing.
And to solve this, they want to make reasoning processes readable and shareable with the open community. They then transition into section 2.3 DeepSeek-R reinforcement learning with cold start.
This section describes how they improved on the DeepSeek-R1-Zero model to build the DeepSeek-R1 model. They took inspiration from their previous model, but wanted to create a better version.
They mention 3 main goals for this model. They specifically want to address the cold start problem, create a user-friendly model, and introduce a pipeline to train the DeepSeek-R1 model.
It's good they stated their goals. They are very clear on how they want to make the final model. Now they begin to discuss cold start, which they define as the inability of the model to perform without curated data sets.
They are saying that to solve this, they constructed a small amount of long chain of thought training sets with human verification. They are fine-tuning the DeepSeek V2 base model with this dataset.
It really shows the contrast between the two models. The first was reinforcement learning from the base model, while the second is reinforcement learning from a fine-tuned base model. What does page 9 have to say about the final model?
Let's find out.
Okay, on page 9, they outline the specific include requirements of DeepSeek-R1, summarizing the problems they were trying to address.
They're targeting the lack of readability of the previous model. They mentioned the content was not suitable for reading due to many mixed languages and lack markdown formatting. They want the responses to be more readable and emphasize the model's potential to perform better.
Now we get into section 2.3.2, reasoning-oriented reinforcement learning. They state they apply the same large-scale reinforcement learning training process employed in DeepSeek-R1-Zero.
They also observe that CUT often exhibits language mixing, particularly when RL prompts to involve multiple languages. They fix that issue by introducing a language consistency reward.
They are trying to incentivize the model to be consistent with the language it chooses. They acknowledge that improving readability will have a minor effect on the performance, then conclude by saying, "We combine the accuracy of reasoning and the language consistency reward, and treat it as the final reward."
It's great that they are transparent about the trade-offs they made. Then they transition into section 2.3.3, rejection sampling and supervised fine-tuning. This seems to be the final step for the model.
They mention that they are performing SFT, and that this primarily focuses on reasoning. They mention they are using other data to enhance the model's capabilities in writing, role-playing, and other general-purpose tasks.
They state that for the reasoning data, they curate reasoning trajectories by performing rejection sampling from the checkpoint from above RL training. They're using their checkpoint from the reinforcement learning model and then doing another round of refinement.
And they are also including additional data that was not used in DeepSeek-R1-Zero. They mention that their incorporated output is sometimes chaotic and difficult to read, which they then fix through sampling highly inspected and retain only the correct ones. They also collect data to train a mixed reasoning training sample. It sounds like this is all they need to complete their model training.
It seems like they are taking extra care to make sure that the final models are as accurate as possible. I'm curious what page 10 has in store.
Let's find out. All right, on page 10, it seems they are wrapping up the approach section, discussing their non-reasoning data.
They state that for non-reasoning data, such as writing, factual QA, self-cognition, and translation, we adopt the DeepSeek V3 pipeline. This is how they made their models capable of more than just reasoning.
They also mention they do not provide a code response. Then they state they collected a total of approximately 200 training samples that are unlabeled for reasoning. It seems they've collected all their data to train their final model.
It is impressive that they were able to collect that much data. They are fine-tuning the DeepSeek V3 base model for 2 epochs, and their total dataset was about 800K samples.
They then transition into section 2.4, reinforcement learning for all scenarios. They had previously described the RL process for the reasoning tasks, and now they are talking about RL for all tasks.
They are stating that to further align the model with human preference, they implemented a secondary reinforcement learning stage aimed at improving the model's helpfulness and harmlessness.
Right, they're focusing on all aspects of training an LLM, not just reasoning. They mention they are training the model using a combination of reward signals and diverse preference data, and that they are using 2 roles to capture human preferences.
They focus exclusively on the final summary and mitigate any potential biases, harms, or harmful content. It's a very thoughtful process.
Now they get into section 2.4.1. Distill empowers smaller models with reasoning capability. This is a similar process to what they described earlier. They are going to use their previous models to train their smaller models.
They mention they are using models like Qwen, Llama in their distillation process, and that their distilled models are also very performant, specifically Qwen 2.5.14b, Qwen 2 1.57b, and Llama 3 Instruct.
They select Llama 3.3 because its reasoning capability is slightly better than that of Llama 3. And they apply only SFT in their distillation process. Han do not include RL. This shows a key difference in the training processes.
It seems like they are wrapping up all the different training methods. Let's see what the next section has to say about the results.
Sounds good. All right, we're on page 11, and it looks like we're finally in section 3, experiment, detailing the actual experiments.
They state they evaluate models on an MLU and a number of other benchmarks, including MMLU Pro, MADI H500 DOP, GPQA, and more. They mention their evaluation follows the setup in DeepSeek V3.
It's good that they are following a well-established process. They also mention that the models were evaluated using both zero-shot and few-shot setups, and that the original prompts are few-shot.
And for code benchmarks, they mention that the human-animal math dataset covers 8 mainstream programming languages.
And the Codeforces dataset is evaluated using problems from 10 Div.2 contests. They state that their outputs are capped at a maximum of 12,768 tokens, using a diff format.
They state that they are testing against several strong baselines, including DeepSeek V3, GPT, and more, as well as the open-source model QuenQS Preview.
And all their models used a maximum generation length of 12,768 tokens. It's good they are specifying all these variables to show consistency. What will the final page reveal?
Let's move on and find out.
All right, we're on the final page 12, where they are detailing the results of the experiments and their conclusions.
They begin with section 3.1, DeepSeek-R1 evaluation, and they state that DeepSeek-R1 demonstrates superior performance compared to DeepSeek V3 on knowledge-based benchmarks with significant gains through reinforcement learning.
They also mention that their model excels on FRAMS, a long context-dependent QA task. This shows their model's complex multi-step reasoning abilities and highlights the potential of reasoning models in AI-driven chart.
They also include links to see the results for themselves. The links provided are ChepStew Leader Chat.com and to Tips to Feud Codeforces.com. They now transition into their conclusions, titled Discussion, Limitations, and Future Work.
They acknowledge their approach isn't a own size fits all, and that it's only focused on reasoning. They also admit there are still open issues that need to be addressed.
Specifically, they note the lack of diversity of datasets, and they were not able to explore the optimal scaling of model sizes.
And finally, they say they are in the process of open sourcing all our DeepSeek-R1 models and related code. This is fantastic for transparency and future research.
They conclude by stating that we expect to see increasingly human-like AI in the near future, and that this approach will help create more responsible and reliable AI. And with that is the end of the paper.
Incredible paper. The DeepSeek team really pushed the boundaries of what is possible, specifically with how they incorporated reinforcement learning into their methods.
Agreed. It's fascinating to see how these complex models are being developed and what breakthroughs are possible with the right approach to reinforcement learning. It's a field that's moving at an incredible pace.
Thanks for joining us for this episode of AI with Linkfitty. We'll be back with more insights from the world of artificial intelligence soon.
See you next time.